All right, so we are going to be kind of half and half today. So I got 2 examples that are not in your note packet, and I've got 4 examples that are in your note packet. So if you want to find some space in your note packet to expand this one out, that's fine. If you want to just expand this one out on your own, that's fine too. Okay? So we are on that very last sheet. You can also go, the sheet afterwards, or the side afterwards is open too, if you wanted it all in one spot. Okay? But I'm going to give you a couple of minutes here to expand this logarithm into its expanded form. If I first apply the quotient rule, that. Then if I apply the product rule, I get that on the left one. And I get that one. Now, this purpley purple could also be written as minus but if I'm going to write it with one subtraction sign, I got to put parentheses around it because I'm really subtracting them both off because they're both in the denominator. With me on that, KK? Because y and z are both downstairs. They both have to be subtracted. Okay? This blue right here, this half blue, splits up into what's in here. But I've still got to subtract that. Okay? So I got to put parentheses around that. In the end, what we would want to see here is we would want to see 2 plus 3 log of x minus 4 log of y minus 5 log of z. Great question. Ask it louder. What's the base on this log? 10, right? What exponent can I put on 10 to get 100? 2. Other questions, comments, concerns, or clarifications? Hearing, seeing, knowing any. Condense this down into one logarithmic expression. Agree with me on that? Just as in the last one, the log of 100, common log of 100 is 2. If we have 1, in terms of a natural log, an expression with a natural log, that would be the natural log of e. Okay. X cubed is on top. Y to the 4th is on the bottom. X to the 4th is on the bottom. And E is on top. If it's being added, it goes on top. If it's being subtracted, it goes on the bottom. Now, if you chose to go one more step further, I would also accept that.
Which one's like that?
They're both the same. The left one is what the problem is giving you. And the right one is just the simplified version of it. Okay. Now we'll be in your note packet on that very last page for the remaining 4 examples. Okay. So whether you're solving an exponential equation, like here in the first 2, or if you're solving a logarithmic equation, like in the next 2, the steps that you need to do are basically the same. Okay? So your first step is you need to isolate. You either need to isolate your exponented term or you need to isolate your logarithmic term. Okay? Either way, that's got to be on one side all by itself. Nothing above, below, left, or right of it. Okay? So if I'm looking at number 1 here, my exponented term is 5 to the x power. I need to get that by itself first. Before I can do anything else, that's got to be alone. So the first thing that I would do is I would subtract 4. That's going to give me 3 times 5 to the x power equals 16. Then I would divide both sides by 3. That's going to give me 5 to the x power equals 16 thirds. Now, you've got 2 choices here once you get that term isolated. Option number 1 is you can log or power both sides. I will show that method today. I'll also show the other method too. Okay? Your other option is you can remember the change of forms. Okay? So you can either change your forms or you can log or power both sides. What I mean by that is this. Okay? So I'll actually do option number 2 first. Okay? I've got an exponential. I need to switch forms with it. Well, it's an exponential, so that's going to be log base 5, because 5 is my base, of 16 thirds is my argument, equals x. And then solve it from there.
Solving it from there, just change the base formula.
Change the base formula, yep. So you do log of 16 thirds divided by log of 5, and get you an answer. Yep. Okay. My other way that I could do that is I could take log base 5, let's say, of 5 to the x, and that would equal log base 5 of 16/3. Log base 5 of 5 to a power, that cancels each other out. So this cancels out that, leaving me just with x. And puts me in the same spot. Sometimes doing it this method, well, first off, doing it that method, you don't have to remember anything. You just take it to the log of whatever base you're dealing with. Or take it to that power, whatever the base is in your log. Gets you to the same spot. So now you can go to a calculator and you can say, all right, let's solve this. And I get here x is equal to 1.040100038 on my calculator. Make sure that you get that on yours. I will tell you that if you are using the TI 30s, that when you punch in log or natural log, it opens up a set of parentheses. So after the divide by 3 for 16/3, make sure you close that parentheses before you hit divide again. Everybody with me there?
What is the 16/3 going?
Just because it's a fraction. Or you mean on a calculator?
Or
Or up here?
Yeah.
Because it's a fraction. That's what That's the only reason I put it in parentheses.
How can the x go there instead? Log.
Because logs are exponent finders. So 0.10038. We typically round here in logs. We typically round to 3 decimal points when we get into the answers. We'll typically round to 3 decimal points. Okay? What should we do now, though, at the very end? We should plug it back in and check it just to make sure. So I'm going to take 5. Luckily, all these calculators have the answer key. Oops, I'm going to take 5, and I'm going to raise it to that answer, not just times that answer. Then I'm going to multiply it by 3. Then I'm going to add 4, and I better get 20, and 20 in fact is what I get. If I took the rounded version, I would say 5 raised to the 1.040, then I would multiply that by 3, then I would add 4 to that, and I would get 19.997. But that's rounded, so that's close enough for me. Okay? With that being said, you now try to solve number 2 for x. Isolated my exponential term. This one I'll show switching forms. We're in natural log form, we're in E form. So that means I would need to go then to the log base E of 5/3 is negative x. Well, log base E we just write as natural log of 5/3 equals negative x. So the natural log of 5/3 is 0.510825624 equaling negative x. Divide both sides by negative 1. I get here negative 0.511 as my x value. E to the answer, then times 3, gets me 5, so I get 7 minus 5, which is 2. It checks out. Good? Try one now with a log, number 3. Try number 3 with solving a log. Here we could take both sides, we could put both sides into the exponent on 10, because 10 is the base of our log. Okay. Then we would get here x plus 2 equals 10 to the negative 2 power. Because the power of 10, where the power is log base 10, cancels each other out. Okay. 10 over negative 2 is 1 over 100. Then I need to subtract 2, but instead of subtracting 2, I'm going to subtract 200 over 100. So I get here as an answer x equals negative 199 over 100. You will probably not like the next words that come out of my mouth. Pre-calculus is a fraction class. We are all about fractions. Okay? If you can put your answer in fraction form, that's better. We're an exact class. Okay? You give us exact answers, you get all of the points. You round, you get none of the points. Yes, Ben.
So if I would have left it negative 1.99, I would have gotten the point.
Probably. No. Okay? Looking at the next one, other than the fact that it looks really scary, what do you notice about it? They're both, but there's what? The key word in there is both. There's 2 logs, right? Okay? So can I isolate 1 log if there's 2 logs in the problem? What do we got to do? I got to combine the logs into 1 if I'm going to solve this one. Okay? So if I'm combining these logs into 1 log, then this becomes log of x minus log of x plus 4 to the 1/2 power equals 1, which then becomes the log of x divided by the square root of x plus 4 equaling 1. Now I have isolated the log, correct? Okay. What is my base? 10. What is my exponent? 1. What is my argument? Now what?
Multiply both sides by x plus 4.
Square root of x plus 4, multiply both sides. Okay. Then what?
Multiply both sides by 10.
Multiply both sides by 10?
Right.
Yeah? I would square both sides. Get rid of the square root. Ten squared is 100. Square root of x plus 4 squared is x plus 4. X squared is okay. Now what? Distribute. Mia's giving me a look. What look are you giving me? Oh, but before we can factor it, what do we got to do? Get it all on one side, right? Yep. If it's factorable, there's got to be a factor pair then, right? What are the factor pairs of 400? I'll start you out. 1 and 400 is a factor pair. 2 and 200 is a factor pair. 4 and 100 is a factor pair. 8 and 50. 5 and 80. 10 and 40. 25. And 20 and 20, right? Those numbers, do they have to add up to be 100 or subtract to be 100? They got to subtract to be 100 because it's negative 400 on it, right? Any of those subtract to be 100? No. What does that mean? It means it's not factorable, right? Okay. Now Mia's really over it. Is that why you were over it? Because it wasn't factorable? Okay, well, it's not factorable. Okay. Now you're more over it? Okay. So what are my two choices then left if it's not factorable? Complete the square or quadratic formula? Which one? Which one? We got to do one of them.
Or that formula.
Formula? Why completing the square? So x squared is alone. Yep. And it's even, right? Okay. So this number here, right here, is 1. This number here is even. Complete the square. All day, every day, and twice on Sunday. Because it's much faster, much easier, less stuff to do. Okay? Right? So if I'm going to do that, then I'm going to actually bring this 400 back to the other side. I'm going to set it up like this. Now, this number right here is my B. I'm going to divide that by 2. And then I'm going to square it. That squared number is what's going there and there. So that I get that. Now what? Square root both sides. Is 2900 a perfect square? It's not. Can the square root of 2900 be simplified?
Yes.
To what? Oh, it can.
29 times the square root.
What's the square root of 100? 10. So wouldn't it be 10 times the square root of 29? Because I can't take the square root of 29? Yep. And I'm going to throw a plus or minus on there because we're solving. 2900 is 29 times 100. Square root of 100 is 10. 29 is prime. So. What does the right side become? X minus 50. Okay? Agree with that? Yes? Okay. Approximately how big is 50 plus 10 square root of 29? Because you got to make this check. Approximately how big is it? No. No. Should be like 103 point something. Is that going to, now listen up here, this is kind of important. Is that going to be okay to check back in my original equation? 103.8. Can I take the log of 103.8, subtract off half of the log of 107.8? All good, right? Hopefully I get 1. Okay? Approximately, how much is 50 minus 10 square roots of 29? Around negative 3.8? Can I check that one back in my original equation? Can I take the log of negative 3.8? Nope. So that one automatically, without even trying, that one automatically gets tossed out. Because we have log of x. There's no exponent that I can put on 10 to get a negative number. So my only answer here, it's not plus or minus, and if this were a test question, wink, wink, nudge, nudge, and people put plus or minus, they would be wrong.